Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, welcome to the next lesson. Okay, so a few lessons that we have remaining for the rest of the year are very hands-on. This is one of those lessons. Pythagorean Theorem in 3D. This was a lesson where I'm just going to go ahead and scroll forward to the next page, where what we were going to do in class and what we've done in the past is create a model for the roof of this house. This is the Flat family's house. And we're going to use cardboard and some straws and either string or dental floss, and you're going to work in your teams, and you were going to recreate this rooftop. Not really going to happen too easily, although any of you that feel like getting a piece of cardboard and a straw and cutting it and putting a hole there and then attaching those there and going through the mock measurements of those, please feel free to do that. You might enjoy yourself. It was actually kind of a fun activity that we would do in class. And in years when we had lots of time, we could spend 2 to 3 days on it. But it required a lot of hands-on and a lot of teamwork. So not really going to work, but I could still walk you through the process. I'm going to start slowing things down a little bit with the CPM lessons, and I'm going to supplement what I do here with my videos with Khan Academy videos. And so today I'm going to go through a couple of problems here, and then tomorrow we'll check homework, and I will present you with a Khan Academy video that you can watch. Sometimes having someone else explain things maybe helps for it to make sense a little bit better. I mean, you hear me a lot, and most of you are doing a pretty good job of watching my videos and understanding these concepts, so not that big of a deal, but we do have time. We've got, a good 4 to 5 weeks of instruction left and not enough lessons to fill up every single day. So I think you'll appreciate us slowing down the pace a little bit more, spreading it out, being able to breathe a bit. So let's get into this lesson, and we'll see if, even without the hands-on, if maybe you can understand the idea of where we see Pythagorean theorem showing up in situations in real life, in three-dimensional situations. So here we go. You've been studying right triangles from a two-dimensional viewpoint. However, often triangles occur in three-dimensional settings. In this lesson, you will build a model, you'll hear me talking about it. Use it to visualize the location of right triangles in a three-dimensional situation, and then make calculations to find the triangle lengths. Okay, so here's the situation. The roof of the Flat family's house is one large flat rectangle. It is parallel to the ground. The TV antenna is mounted in the center of the roof. Okay, isn't that quaint? They don't have cable, they don't have satellite, they're still using TV cameras. Okay, let's go back in time 30 years. So guy wires, these are the guy wires. They keep that antenna supported on the top of the roof. They're attached to the antenna 5 feet below. That's kind of an important measurement there. 5 feet below its highest point. So you see how it goes all the way to the top, and the guy wire, there's a little bit of gap there. That's the 5 feet. And they are attached to the roof at each corner. So there's a corner there, there's a corner there, here's a corner there, here's a corner there. And they're attached to the roof at, doesn't it say? I already read that. They're attached at each corner. These wires support the antenna in the wind. Each guy wire is the hypotenuse of a right triangle. Mr. Flat needs to know how long each wire needs to be to keep the antenna upright. He also needs to find the total amount of wire that he needs. All right, so I'm going to paraphrase a lot of this here because we're not actually doing it, so you don't have to know all the information. I'm just going to tell you, this here said it was attached to each corner, but also you've got a guy wire at the center point. So you've got a total of 8 guy wires there, all attached to the antenna. Every one of these is creating a right triangle. Let me kind of show what's going on here. Let me take a line there. Let me thin it out. Let me make it the color red. All right, so first let's take a look here. You see, if we were to take this as one leg of our right triangle, and then we went in a straight line or along the base of the roof all the way out to that center point, then the guy wire becomes the hypotenuse. And this is the guy wire that's going to be attached to that green dot right there, the center of this side of the roof. And there's a matching one that's going to be on this side, because this antenna is in the center of the roof. Okay, so there's one. Then there's going to be another one. Let me choose this color. There's going to be one here. So once again, you've got your leg of the triangle there, and then you've got another leg here, and you can't tell from this angle, but just think of perspective here. This is perpendicular to the roof, just like it was for that right triangle, and this is a straight line that goes out to the center. If we were to rotate this roof around, this would end up looking the same as that, and then you'd have a hypotenuse right there for another right triangle. Then there's a third one. This one is going to be the trickiest of them all. This, once again, is one of the legs of our right triangle. I'll go in this direction, but then this is going to go to all of the corners. So this one is going to be the same distance to all of those corners, which makes this guy wire yet another hypotenuse. So we're going to have, if you can picture two matching right triangles here and here where I show the red lines, you're going to have two matching right triangles where I've got the blue lines, and then this is kind of like a purplish color. I'm not sure if you can see it through the video, but this one should match this one and that one and that one. So a total of 8 different right triangles that we're going to have to figure out, but then it gets even more complicated there. All right, so for my students, when we would do this in class, I would show them what it would look from the bird's eye view if you flew a drone over their housetop. And they did say that the housetop was a rectangle, but there was a year where it was easier for me to cut out square kind of shaped cardboard rooftops. And since a square is a rectangle, no problem using that. But we're going to assume it's going to be more like this, okay? And in fact, they give us the dimensions of the rooftop on the at the beginning of problem 136. So it says right here, the flat family's rooftop is 60 feet long and 32 feet wide. The TV antenna is 30 feet tall. So I decided to do these renderings. This is the bird's eye view that you would see where it's 60 by 32. But with this bird's eye view, you have no way of kind of viewing how far from the rooftop this point is right there, which would be the antenna right here. So I had to do this rendering, 3-dimensional rendering, where this would be the entire antenna. But remember, the guy wires for the antenna are attached 5 feet from the top of the antenna. So the part that we're going to be working with for the Pythagorean theorem is going to be 25 feet right here. So remember, you've got the right triangle that goes out to here, you've got the right triangle that goes here, and eventually the one that's going to go all the way out to here. Okay, so let's start. What are we going to start with? Let's start with the right triangle. Hold on for a second. I'm going to pause here because I can't remember which one I did my work with first. Hold on. Okay, I'm back. Okay, so we're going to start with this triangle right here, and I'm going to color this red. Go back to here, and so we've got this leg and this leg, which are known lengths. These are the two legs, the A and the B. We know that's 25. We know that is 30. So to find out the length of this hypotenuse, we need to find a squared plus b squared. That will equal c squared, and then we'll take the square root of that number. So what I need for you to do is write down Pythagorean theorem, a squared, or maybe I'll write it here. A squared plus b squared equals c squared. B, you can do a little bit better. There we go. And go ahead and figure out the length of that hypotenuse. I will pause. You pause, and then when you come back, I'm going to reveal this first piece of work that I've got right behind here. All right, what is your distance there? Well, let me show you the work that I did. This is one leg. We take 25 squared, that's 625. This is the second leg, and it's half of the distance from this dimension of the rooftop. So this will be 30. So we'll square it to make 900. And 625 plus 900 is 525. So when you take the square root of that, the square root of 525 is 39.05, blah, blah, blah. Let's just round that to 39 feet. Okay? So we know this guy wire here is 39 feet, and we know we're going to have two of them. So maybe I'll write there, this is going to be times 2. Okay? Now for the next one. Once again, I'm going to pause my video so I can remember what I did here. Hold on. Okay. So the next one is going to be this dimension, this triangle right here. So I'm going to color code this in green and say, all right, so that's 25. So we're going to 25 squared. And what's the distance from that pole to this part of the roof? Well, that's halfway across. Half of 32 is 16. So 25 squared plus 16 squared will equal whatever the hypotenuse is squared, and then we'll take the square root. Go ahead, pause, and when you come back, I'll reveal. See if you got the same thing as me. All right, welcome back. 25 squared we saw before was 625. 16 squared is 256. And when you add those two numbers together, you get 881. So I wonder what the square root of 881 is. 29.7. I went ahead and rounded that up to 30 feet. Let's just deal with nice round numbers if we can, whole numbers, rather than dealing with fractional numbers, because no one wants to cut fractional pieces of guy wire. So how many of these do we have now? We've got one here, and don't we have a matching one on the other side? So that is also going to be times 2. All right, now for the last one. What is the last one, you might say? Well, we've got 4 guy wires that go from the antenna to the corners. But we've got a problem here. The problem that we have is we don't know the distance from the antenna's base all the way across the rooftop to that corner. So if we don't know this leg of this right triangle, we can't figure out the hypotenuse. Luckily, we know what this distance is, and we know what this distance is. So now let's go back to our bird's eye view. If you can picture this distance right here as the same as this distance right here, then that line that you see right there is going across the rooftop. That would be the hypotenuse of this triangle right here. So we've got to figure out what this distance is right here, which would match this one, so that we can figure out the hypotenuse of this 3-dimensional right triangle and the length of that guy wire. So your next task is to figure out what is the distance from here to here. So we're going to take this dimension right there, which is 16 feet, and this dimension, which is 30 feet, and use Pythagorean theorem for that. Go ahead and pause the video, see if you can figure out what this is. Okay, welcome back. While you were away, I fixed my B, so I'm sure you're much happier with that. Let's see what we've got here. What we have here is 30 squared is 900, 16 squared is 256. When you add those together, you get 1156. So what is the square root of 1156? Ooh, let me do that again. 1156 is a perfect square. How do you like that? This distance right here to here is, let me write this in purple. This distance right here is 34 feet. So if we know that this is 34 feet, then we can now figure out what that guy wire is going to be. Okay, so 25 feet squared plus 34 feet squared gives you a number whose square root will tell you the length of this guy wire. Go ahead and pause. Come back to me when you think you're ready. All right, let's see how you did. 25 squared is 625, as we've seen here and here. 34 squared is 1156, and we knew it there, right? Because we took the square root of that and got 34. So when you square it, it's going to get you back to the 1156. Add those together, you get 1781. Let's see what the square root of 1781 is. 1781, square root, and let's just round that off to 42. All right, so that means we've got ready? 1, 2, 3, 4 guy wires that go to the 4 corners that are all the same. Every single one of these distances, here to here, all those legs, those right triangles are all 34 because it's in the center, right? And the hypotenuse, or I'm sorry, this leg is always going to be 25. So that means we've got 4 of these that are 42. So if we need to buy guy wire, we've got to figure out how much guy wire to purchase. And so let's take 2 times 39, which I believe is 78. We're going to take 2 times 30, is going to be 60. And this one, we didn't actually need guy wire for that because that was the dimension across the flat top of the roof. We used this to find the guy wire distances from here to here. So we need 4 of the 42s. 4 times 42 ends up equaling 160 plus 8 is 168. And so the total there, I'll just use my calculator since I've got it so handy. 138 plus 168 means we need 306 feet of guy wire. And so that's, you go to Home Depot, see if you can get 306 feet of guy wire. I'm sure they'll sell something to you there. And then it says here for problem B, wait, what did I say it was again? 306? Yeah. So let's just go ahead and declare our answer here. 306 feet of guy wire is needed. Nothing like a good, complete sentence to declare your answer. All right. Mr. Flat needs to buy wire at his local hardware store. He decides to buy an additional 10%. Not a bad idea. You know, you mess up with the cutting and you just end up having to go back to the store. So what is 10%? What is 10% of 300? Oops, I almost wrote the answer. 10%, which would be, I guess, 30, right? So I'm just thinking, you know what? 336, just be on the safe side, maybe round it up to 340. I don't know how they sell it. But an additional 10%, that ends up being the final amount, about 336 to 340 feet of guy wire that will be needed to secure this antenna. So there you go. Took us 18 and a half minutes to do this instead of a couple days. And you didn't have to struggle with all the guy wires and creating the model. All right, here's another one. This is kind of interesting. It says a child's shoebox measures 4 by 6 by 3 inches. What is the longest pencil that you can fit into this box? Okay, so I recommend you draw a rendering of this box. Remember how we draw 3-dimensional looking shapes? Start with a rectangle, then do 1, 2, 3 diagonals off of that, and then complete the process. And then if you want to put in those dotted lines, go ahead and do that. Okay, so this is mine. Now, the longest pencil that you could fit in, let's just think about this for a second. You could fit a pencil this way. That would be what? That's the shortest dimension. That must be, is that our 3 inches? I'm not quite sure. How did I do this? Maybe this is my 4, that's my 3, and this is my 6. That's probably what my intention was there. So this one would be 4 inches, but is that the biggest one that you could fit in there? No, you could lay it down flat, and you could have a pencil that was 6 inches, right? Or what if we decided to put it flat on the bottom across? Is that really? Hold on. Stop it. Here. Yes, there we go. You could fit a pencil in there, so we would have to use Pythagorean theorem to figure out what that distance is, with this being a leg and that being a leg. But that's not even the biggest pencil you could fit in there. The biggest pencil you could fit is this one right there. That goes from the bottom left-hand corner to the upper right-hand corner. So this ends up being a similar process to what we did over here when we had to find that last measurement of these 4 guy wires. Is we had to figure out the distance across the bottom first and use that as a leg to this right triangle to find the length of that guy wire there. We're going to do the same thing here. So I would like you to do this, and I'm telling you, there might just end up being a problem on the chapter test that looks something like this. So be ready for it, okay? I'm going to pause and do the work. You pause and do the work, and we'll see if we get the same answers. I haven't done any work yet, but have you labeled these 3 sides? That's kind of important. When you, after drawing this box, make sure you get those sides labeled. Okay, did you get the distance from this corner of the bottom of the box to that corner of the bottom of the box is 6.7 inches, rounded off? Remember, this is the same length as that, which is the same length as that. So this is 3 inches, that's 6 inches. So 3 squared plus 6 squared is 9 plus 36 is 45. The square root of 45 is about 6.7, which makes this hypotenuse, this distance from corner to corner along the flat bottom of the box as 6.7 inches. All right. So now that we know this distance here is 6.7 inches, and we knew this was 4 inches because this is the same as this, which is the same as this. They're all the heights on these are the same, which are 4 inches. And we're going to take 4 squared plus 6.7 squared equals c squared. Now, notice this number right here. If you just in your calculator did 6.7 and then squared it, you would not get 45. But remember, when I took the square root of 45, I got a number that I rounded off to call it 6.7. But if I'm going to turn around and square this number, I'm not squaring 6.7, I'm squaring 6.70823, or blah, 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 blah. So watch, it'll go back to 45. So I didn't bother multiplying 6.7 times 6.7. I just knew that if the square root of 45 was 6.7, rounded off, then when we theoretically squared this again, it would go back to 45. So I wrote that down. 16 plus 45 is 61. So what is the square root of 61? 7.8. So that means that this pencil right here would be the largest pencil that you could fit in this box, could be 7.8 inches long. Okay, so these are just 2 situations where in real life, with 3-dimensional solid objects, you will find right triangles, and you can find distances in real life by applying the Pythagorean theorem to those situations. Okay, so go ahead and do your homework for today. Tomorrow, I'm going to include the answers to the homework, the worked out solutions, as well as a Khan Academy video on this very thing, but just some different people talking about different situations. And I'll have a check for understanding tomorrow as well. So good luck on everything, and I'll be getting it on the homework pretty soon. All right, bye.
Hey, feeling good, like I should. When in dark, walk